Okay, let's dive into this. Welcome to today's Explainer, where we're tackling a seriously critical, high-stakes topic for the 6th edition BCBA exam. We're talking about measurement artifacts. You know, if you're gearing up to sit for this test, mastering the flow of data is everything. It is absolutely crucial. But what happens when the very tools you're using to measure behavior actually, well, distort the reality of what's going on?
I want you to honestly consider this for a second. Are your graphs lying to you? It's a pretty heavy question, right? In behavior analysis, data guides every single clinical decision we make. But here's the catch. If you choose a discontinuous recording system without truly grasping the mathematical bias that's basically hardwired right into it, that system will completely distort reality. Literally, your graphs are going to tell you a story that simply isn't true.
Now, what's really interesting about this slide is the sheer visual disparity here. Look at the bar on the left. That represents our true duration data. This is the actual objective reality of how long a behavior occurred, and as you can see, it's quite low. But then look right next to it. That second bar, that's the data generated by discontinuous tracking. No way, right? It is highly inflated. This overinflated data completely misrepresents the true duration of the behavior we're actually trying to track.
Section 1. The problem. Let's look at measurement artifacts.
So, what exactly is a measurement artifact? Well, it's a distortion of data caused by the specific recording system you used, making the recorded behavior appear totally different from reality. It's almost like a funhouse mirror for your data. I want to really highlight this because the creators of the test absolutely love to throw scenarios at you where you have to spot these disguised distortions. They want to make sure you aren't just blindly staring at numbers, but that you're actually analyzing the methodology behind those numbers. So, let's master the mechanics of exactly how this overestimation and underestimation actually happens.
Section 2, Analysis Part 1. We're looking at partial interval overestimation.
We're going to examine our first specific recording method and its mathematical bias, which is partial interval recording, or PIR. Now, to really get PIR, you have to understand that this system really only cares about one single super simple question. And that question is, did the behavior happen at any point? That's it. It doesn't track for how long, it doesn't care about the severity, it simply asks, did it happen at all within our defined window of time?
Let's walk through a physical timeline to see this in action. I want you to imagine a clean 10-second interval block. At 0 seconds, nothing's happening. Then, exactly half a second into the interval, your client engages in a behavior. Let's say they script for just a tiny half-second blast, barely a blip. And then, for the remaining 9.5 seconds of that block, they are completely quiet.
But here's the kicker. Because we're utilizing partial interval recording, that tiny fraction of time triggers a full interval checkmark. Look at the visual math here. A half-second blast equals a 10-second checkmark. You slash a bold mark right over the whole interval block. I mean, think about what that does to your graph. When you plot this data out, that tiny half-second occurrence looks exactly the same as 10 continuous seconds of behavior. It just completely inflates the data.
So, the crucial point is this summary of the mathematical bias. PIR systematically overestimates high-rate behaviors, and it systematically overestimates total duration. Why? Because it counts a mere fraction of time as a whole block event. By using this system, you are structurally guaranteeing that the behavior will look way more frequent and longer lasting than it actually is in reality.
Section 3, Analysis Part 2. Let's move to Den and see how this builds into whole interval underestimation.
Okay, let's swap out our timeline block for a whole interval recording presentation, or WIR. I want you to picture a brand new scenario. Your 10-second interval starts. The client begins the behavior right away. 1 second, 5 seconds, they're still going strong. But at exactly 9 seconds, the behavior drops off. They break right before the finish line. So out of a 10-second block, the behavior was present for 9 solid seconds.
So, what goes on our data sheet? A giant red 0 drops onto the block. I know, it sounds crazy. Despite almost completing the entire interval, and despite the behavior dominating literally 90% of that time frame, because it didn't last the whole continuous interval, it doesn't count.
And this brilliantly illustrates the core issue with whole interval recording. It forces severe underestimation. It dramatically underestimates the true occurrence of the behavior. If someone just blindly looks at your final graph, they're going to see a 0 and assume the behavior simply didn't occur. They are entirely missing the reality of that 9-second stretch.
Section 4. The solution. Here is your exam shortcut.
This right here is the clear, binary rule you need to easily match the correct recording type to the behavior goal on the test. I want you to directly anchor this shortcut in your mind. If your goal is to decrease a behavior, you want to use PIR. You use it precisely because of its high sensitivity. Even a brief instance gets flagged, ensuring you don't miss any occurrences of the behavior you're actively trying to reduce. On the flip side, if your goal is to increase a skill or behavior, you use WIR. Since it underestimates data, using WIR for skill acquisition forces a strict mastery path. The learner absolutely has to sustain the behavior for the entire block to get credit.
So, are you ready to break down the matrix? Look, knowing the definitions is one thing, but on exam day, these concepts are going to be deeply disguised inside really long case scenarios. Log into your student portal right now. Hit today's Level 3 measurement quiz blocks and practice spotting these artifacts in action. And I'm going to leave you with this to think about as you study. If our standard data tracking systems inherently distort reality by mathematically overestimating or underestimating behavior, how will you ensure your clinical decisions as a future BCBA remain purely objective? Keep that question in mind and happy studying.